if n is a positive integer and r is the remainder when 4 plus 7n is divided by 3, what is the value of r? So what is the value of our remainder when we divide this expression by 3? So one thing to keep in mind, even if you have no idea what this question is asking, if they are asking for the remainder when we divide something by 3, we only have 3 options, right? Our options are 0, 1, and 2. And so no matter what, we are already very limited to start out and what our values for r could possibly be. So with that in mind, is there anything else from the prompt? We know what n has to be a positive integer. And so can we, if we try just testing some values for 4 plus 7n, and see if that tells us anything. So if n is equal to 1, 4 plus 7 is just 11. If n is equal to 2, we got 4 plus 14, which is 18. So we're just adding 7 every time. So these are possible values for 4 plus 7n. And so what is the remainder when we divide by 3 for each of these guys? 11 divided by 3 is going to be 3 remainder 2. 18 divided by 3 is going to be 6 remainder 0. So 25 divided by 3 is going to be 8 remainder 1. And then 32 divided by 3 is going to be 10 remainder 2. Okay, so it just seems like every 7 numbers, our remainder changes by 1, and then the cycle repeats. So we should have a pattern of 201, 201, 201 if we kept going infinitely. So not super helpful. I don't know, but let's see if it comes into play later on. N plus 1 is divisible by 3. Okay, so this n plus 1 in this case, let's find what our n plus 1 values would be. 12, so that works. And so in this case, so our remainder 2 is possible. 18 plus 1 would be 19, so that doesn't work. This guy wouldn't work. This guy would work, and that's another remainder 2, because 33 is divisible by 3. So maybe we should come up with a few more values here. 39, 46, 53. So n plus 1 is not divisible by 3. N plus 1 is not divisible by 3. 54 is divisible by 3. So what's the remainder when 53 is divisible by 3? It's 18 times 3. 50, 54, so it should be 17. 17 remainder 2. So it looks like it's always going to be remainder 2. So I'd say this guy's sufficient. Statement 2 says n is greater than 20. Okay, well, by itself, I got 2 values right here with different remainders, so that's insufficient. So we're just left with A.